My name is Erin Lin, and I'm an assistant professor in the political science department here at Ohio State. I study the legacy of war on development, and I focus on bombing. In particular, the fact that not all bombs actually detonate. One of my key findings is that it's actually when bombs hit fertile agricultural soil, areas where the ground itself is already relatively soft, that there's a lot of lush ground cover that's covering the surface. This essentially provides a cushion for the trigger fuse that's designed to go off on impact but doesn't meet enough resistance to detonate successfully. Now, this is actually kind of counterintuitive because what ends up happening is that it's these agricultural fields, the most fertile areas, that tend to be the least productive because they are so dangerous for people to enter and to access and to farm. One of my articles coming out of my dissertation focuses on this particular relationship between high fertility soil, unexploded ordnance, and household poverty. And it's recently been covered by The Economist, in which they were able to capture some of my ethnographic data, as I've spent a couple of years living out in the jungle villages and the Cambodia-Vietnam border. But I'm also trained in econometric analysis, and I've done large end data analysis using declassified U.S. Air Force pilot records, soil fertility maps from the Ministry of Agriculture in Cambodia, as well as geocoding the Cambodia household census myself. And so what was really wonderful about this coverage from The Economist is that it's given me a lot of opportunity to both share this research in DC and now serve on the Board of Trustees for Mines Advisory Group, which is one of the top humanitarian demining organizations. And working with this organization has actually given me the opportunity to engage in a lot of new interdisciplinary research questions that I would love to find future collaborators to work with. For instance, what is the degree to which these leftover bombs can leach toxic materials like TNT, heavy metals, into the soil system, and how does this impact soil health? How does it impact plant health? And what are the implications then for human health, given that a lot of humans do consume the plants that are grown in these post-conflict fields? Related to that is what is the best way to remediate some of these soil environments? And are there ways that we can incorporate indigenous knowledge and traditional ecological knowledge in the remediation process? Another question that I would love to explore revolves around what are the ways that we can make the process of finding unexploded ordnance and removing it safer for the professional deminers involved. For example, I have some work with computer engineers here at Ohio State where we use high-resolution satellite data and a machine learning algorithm to count the number of bomb craters and relate that to the payload drop coordinates from the declassified U.S. Air Force records to estimate the number of bombs that should be left in a particular village. And I think it's really important to get people interested in these particular questions and topics because the more research that we can generate about unexploded ordnance and their implications, I think the more options that we have to help people living in these particular communities, because for them, it can mean the difference not only between poverty and wealth, but it can also mean the difference between life and death.